Today we will talk about Kirchhoff's rules. We have two rules. The first one is called the point rule, which talks about the current. Now, the point rule says that sum of the currents at any point is equal to 0. To apply this rule, we have to consider any current that enters the point as a positive quantity and any current that leaves the point as a negative quantity. Now let's take a look at the example that we have here and take a look at point B. Now we want to apply the point rule to point B. In this case, I1 enters point B, so it's going to be considered as a positive quantity. So to apply this rule, I1 is positive, and then I2 leaves point B, so it's a negative quantity, and then I3 enters point B, so it is a positive quantity. These are all the currents that we have, so this sum is equal to 0, from which we can conclude that I1 plus I3 is equal to I2. So what we will do in this experiment is that we will measure the current in each of the three branches and then apply the point rule to our measurements to see whether or not our data satisfy the point rule. Now for the second part of the experiment, we will be talking about the loop rule, which says that sum of the voltage differences around any closed loop is equal to 0. Now, before we apply this rule, there are a couple of things that we have to understand. The first one is that for any battery, let's say that this is a battery here, always the positive side of the battery has higher potential than the negative side. So when we move from negative to positive, this means that we are moving from a point of low potential to a point of high potential. Now, when we move across a resistor, it is a little bit different because it depends on the direction of the current. So if you have a resistor, and let's say that the current is moving in this resistor to the right, here is the current, always the current moves from a point of high potential to a point of low potential. So in this resistor, if we are moving to the right, this means we are moving with the current. So we're moving from a point of high potential to a point of low potential. So in this example, we will represent any point that has high potential with a plus sign and any point that has a low potential with a negative sign. So moving to the right through this resistor means that we moved from high potential to low potential. So there is a drop in potential. If we move to the left in this resistor, this means that we move from a point of low potential to a point of high potential, which means there is an increase in potential. Now let's take a look at the example on the right side, and we will apply the loop rule to the upper loop of this example. Now before we apply the loop rule, we will first decide in which direction we want to travel through the loop. So let's represent our travel by this arrow here. So we will start at point A and move clockwise in this upper loop. Now before we start applying the rule, first we want to represent any point that has high potential with a plus sign and any point that has low potential with a negative sign. We will do this for each of the circuit elements that we have. So first of all, for the battery E1, always the positive side of the battery has high potential and the negative side has low potential. Now for the resistor R1, notice that the current I1 is moving in this shown direction, which means that it moves inside the resistor R1 from left to right, which means that the left side has higher potential than the right side of R1. For R2, notice that I2 is moving to the left, so the right side of R2 has higher potential than the left side of R2, because the current always moves from a point of high potential to a point of low potential. For the battery E2, again, the positive side of the battery is on the left, so this is the high potential side, and the negative side is the low potential side. Now, we are ready to apply the loop rule, which again says that sum of the voltage differences around a closed loop is equal to 0. Let's start at point A and move clockwise. The first item that we will see is the battery E1. And when we travel clockwise in the upper loop, so I'm going to start at point A here and move in this direction. So I'm going to move through the battery E1 from a point of low potential to a point of high potential, which means that there is an increase in potential. In other words, the potential difference is going to be between the two sides of the battery is going to be a positive quantity. So I'm going to write plus, and the voltage difference across the battery is E1. The next item that I will see is going to be the resistor R1. And when I keep moving in the same direction, I am moving from the plus side to the negative side of the resistor R1, which means from point of high potential to a point of low potential, which means that the voltage difference in my path is going to be a negative quantity. So I'm going to write minus, and the potential difference across R1, let's keep it as delta V across R1. Now let's keep going. The next item, so we are here now, and we will move in this direction and then keep going in the upper loop. Now the next item that we will see is going to be the resistor R2, and we are moving again from a point of high potential to a point of low potential, which is going to be a drop in potential or a negative potential difference of value delta V R2. And then the next item that we will see is going to be the battery E2, and we're moving from a point of low potential to a point of high potential. So this is an increase in potential of value E2. Now after E2, we arrived at point A again, where we started. Here is point A. So we closed the loop, so this sum should add up to 0. So in this experiment, we will have a similar circuit with two loops. So we will apply the loop rule to the upper loop and then to the lower loop. But in this case, we will be measuring the voltage differences using the voltage sensor in each case. So we will measure the voltage difference across each of the circuit elements, and then plug these numbers here under the equation after we apply the loop rule, and see whether or not our data adds up to 0, or experimentally it will be a very, very small number, normally less than 0.1 volts. Now, one more thing that you will do after this is basically to measure the voltage difference between points A and B. So we want the value of VA minus VB, or VB minus VA. Now to do this, we will follow the same procedure as the loop rule, but instead of closing the full loop, we will start at point A and end at point B. A question about this will be, for example, find VA minus VB. So I'm going to start at point A and write down VA, and then I'm going to move from point A to point B. Let me move from point A to point B using the middle branch in this direction. The first item that I will see after point A is going to be the battery E2. So, and I'm moving from high potential to low potential, so it's a negative, or drop in potential, negative of value E2. The next item that I will see is going to be the resistor R2, and I'm moving from low potential to high potential. So this is an increase in potential of value delta V R2. And then after R2, I arrived at point B, so I'm going to stop and write down equals VB. Then I will solve for VA minus VB, which equals to E2 minus delta V across R2. And again, the value of E2 and the value of delta V across R2, in this experiment, they are obtained from the voltage sensor. So you just plug the numbers and find the value. Now notice that there are two more branches that I can use, which are the upper branch and the lower branch. Now, since we used the upper branch in the previous example, I'm going to use it also in this example. So the other route that I'm going to follow to find the voltage difference VA minus VB is going to be using this route right here. Okay, so this is using route 1 and route 2. So here is route 1 and here is route 2. So I'm going to start again at point A and write down VA. After this, I will pass through battery E1 and I'm moving from low potential to high potential. So there is an increase in potential of value E1. And then moving from high potential to low potential through R1. So there is a decrease in potential of value delta V across R1. And then after the resistor R1, I arrived at point B, so I'm going to stop and write down equals VB, and then solve for VA minus VB, which equals, in this case, minus E1 plus delta V across R1. So in this example, we used two routes to find the voltage difference between points A and B. In theory, the two values should be equal to each other, but experimentally, we may find only very minor differences between them. We will connect this circuit diagram using the interface and three resistors. R1 is going to be the 10 ohm resistor, R2 is the 5 ohm resistor, and R3 is the 20 ohm resistor. For the battery E1, we will use source number 1 of the interface. And for the battery E2, we will use source number 2. This right here is called the BNC adapter, which allows us to connect banana plug wires into this BNC connector, which looks similar to this one. Now, to start connecting a circuit like this, first of all, we will arrange our items like they appear in the diagram. So first, I'm going to put R1, and then put R2, and then R3. And then I'm going to start by connecting branch by branch. So let's take a look at the circuit diagram. In the first branch, we have the battery E1 connected with the resistor R1. So I'm going to connect a wire between the positive side of E1, which is right here, to the left side of R1. I'm going to, so I'm done with the first branch, so let me move to the second branch. In the second branch, the positive side of the battery E2 is connected to one side of the resistor R2. So I am done with the second branch as well. Now for the third branch, there is only R3 by itself. Now I am done with the three branches. Next, I'm going to connect the three branches together. So if you look at the diagram right here, you'll see that the right side of R1 is connected with the right side of R2, which is connected to the right side of R3. So I'm going to take two wires, connect the right side of R1 with the right side of R2 with the right side of R3, just like this. So I joined the right side of my circuit, which is this side right here. Now let me move the other side, in which we have the negative side of E1 connected to the negative side of E2, and both of them are connected to the left side of R3. So here is the negative side of E1. We will connect it with the negative side of E2. And remember, as always, the black is the negative for the batteries. Both of these wires are connected to the left side of R3. Now let's double check our connection by following the two loops one by one. So for the first loop, we have the battery E1, the resistor R1, the resistor R2, and the battery E2. So let's take a look here. So we have E1 connected to R1, R1 is connected to R2, and R2 is connected back to E2. The negative side of E1 and E2 are connected just like the diagram. So this completes the first loop. Now let's take a look at the second loop. Let's start with the positive side of E2. It is connected to one side of R2. The other side of R2 is connected to R3. The other side of R3 is connected to the negative of E2. So this loop here is the second loop. So we have the first loop connected and the second loop connected. So always double check your work to make sure that you are not missing any of the wires. Your task in this experiment is to measure the current in part 1 in the 3 branches, in the first branch, the second, and the third branch. So here in this example, we are measuring the current in the first branch of our circuit. Notice how we have to cut the circuit and insert our ammeter. This can be the ammeter or it can be the current sensor as well. Both of them should be handled in the same way. In other words, they should be connected in series with your circuit. Otherwise, you may end up burning the current sensor or having very bad results. So let's take a look at our circuit right here and see how we can measure the current in the first branch. So here is the circuit. So notice how we have the ammeter connected between the battery E1 and the resistor R1. Okay, so I'm going to take my current sensor in this case, and it has 2 wires. Okay, so I'm going to remove this wire that connects the positive of E1 with R1 and replace it with the current sensor. Now the circuit looks like this. So all of the current in the first branch will pass through the current sensor. Okay. Now you don't have to connect the red with the red and the black with the black, because we don't know. We will pretend at least that we don't know the direction of the current. Now, if you get a positive reading from the current sensor, this means that the current enters the red side and exits the black side, which means that it is moving in this direction. If you get a negative sign, this means that the current enters the black side and exits the positive side, which means that the current is moving in the opposite direction. Now, so this way you can measure the current in the first branch. You will repeat the same process for the second and third branches. So after you're done with this reading, disconnect the current sensor and restore your connection. This is very important. Here we restored our connection, and repeat the same process for the other 2 branches. Now to measure the voltage, using the voltage sensor is much easier because the voltage or the voltmeter is connected in parallel with each element. Let's take a look at the circuit diagram. Notice how in this example we have the voltage sensor connected in parallel with R3 to measure the voltage difference across the resistor R3. So to do this on our real circuit, we will take the 2 sides of our voltage sensor and connect them in parallel with the resistor R3. So this way you are measuring the voltage difference across R3. Notice that I don't have to change anything in the circuit. Once I am done with this reading, took the reading and everything, then I can remove it and move it to another circuit element, and so on. To set up the program for this experiment, we will open the signal generator, set output 1 to a DC power supply, and set its voltage to 5 volts. Then don't forget to check the automatic mode. And then for output number 2, we want this to be a DC of 6 volts. Automatic. And then for the recording conditions, we want the program to record data for only 1 second. So we will go to recording conditions and set the stop condition to time-based, and then choose 1 second. This way, the program will stop automatically after 1 second. Now, in part 1, we will measure currents. So we will add a current sensor to channel A. If you type C here, here is the current sensor. And then to display the reading of the sensor, we will use the digital display and select the measurement, set it to the current. And here you can see it is in amperes. Now we are ready to move to part 2 of the experiment, in which we will be measuring voltage differences across each of the 5 circuit elements that we have. So for this reason, I'm going to delete the current sensor. Press on delete on the keyboard and then yes. And then replace it with a voltage sensor. And I also unplugged the current sensor from the interface and replaced it with a voltage sensor. So now we have the voltage sensor connected. So we will change this reading from current to voltage.